Welcome to Tulsa Tech's Motorcycle and Watercraft Facility. Today we have this 2013 Yamaha XT250. We'll be diagnosing a no-crank situation using our troubleshooting guide and wiring diagram to help us locate our components and their correct wire colors. Before testing, you'll need to remove the seat, side covers, tank, and toolbox. Doing so will only help us better access our components that need testing.
First, we need to locate and check the main fuse and the ignition fuse. The main fuse we need to test is located on the battery side of the starter relay. It is a 30 amp fuse. The other 30 amp fuse that we have on this side is simply a spare. The ignition fuse is located in a little fuse box. It's labeled IGN, and it is a 10 amp fuse. We remove those fuses and test them for continuity. Now, before we actually test our fuses, we'll need to make sure that our main switch is in the off position. And as you can see, the green one that we have here is our 30 amp, and the red one is our 10 amp. And to test those, we will turn our multimeter on. We'll look for this continuity symbol, which is this yellow, kind of looks like a sound wave rising up there. In order to switch from ohms, because that's the setting that it's in right now, I'll hit this little yellow button here. And then we will test cross there, and we should hear a beep to make sure that it is good. And if we don't, then we've got a problem. Hey. Alright, it looks like they are both good. Next, we need to check the battery in both an unloaded and a loaded state. Now, to check for the unloaded state, we'll need to set our meter to volts DC and simply place our probes, the black probe on the negative terminal and the red probe on the positive terminal, and take our reading there. As you can see, it is 12.44 volts. The loaded state, we need to have our ignition turned on, or key on, to provide a load to the battery. So it turns on some lights and test to those terminals again. You can see we are down to 12.14 volts. Now, after checking the battery, our next step is to check the starter motor operation. In order to do that, I will need a 1/4 inch drive, socket wrench, and an 8mm socket. Now we'll unhook our wires from our starter relay. Now that we have our wires disconnected, we will actually touch the two ends together to try to start the starter motor. Just as a fair warning, it will produce a spark, so we'll have to be prepared for that. Hopefully this works out all right. And it does. And now we will test the starting circuit cutoff relay. To locate that relay, we'll have to pull back the starter relay. Back these two relays here, it's tucked back behind those. Once we get that out, we'll disconnect the relay from its harness and test the relay. Our wire colors for the relay is a red with black tracer, blue with red tracer, blue with white tracer, and a blue with black tracer. Alright, we will need to be testing for continuity across points 3 and 4. So again, we'll set our meter, and then we had to connect our wires from our battery to points 1 and 2 on the relay to make sure it's operating so we can test for the continuity. So hopefully we got this right. We will get some noise going on. Hey. And we do have continuity. Now that we finished our starting circuit cutoff relay test, we're going to have to check our diodes. Our diodes are located here on the frame. They are normally secured with a lot of electrical tape, so all the wire colorings are covered up attached to this frame. But for our diodes, we have a brown with blue tracer and a blue with white tracer on diode number 1. And diode number 2, we have some sky blue some red with blue, or I believe blue with red, excuse me, and also some blue with yellow tracers on there. Now to test those, we'll just remove them from the connectors, like so. Now to test our diodes, we will need to set our meter to the diode setting, which is here. We'll change that so we can see that corresponding up here. And we'll test across diode A, which I guess should have no reading there. And that is correct. According to the specs on the book, shouldn't get any continuity or any reading on that. And now we'll test across diode B. We'll start on this side. And that wire color to there, we are good. And if I reverse it, I shouldn't get anything, which we don't. Go ahead and test this side. And if I reverse it, should get no reading, which we don't. The next step is to test the start relay. To do that, we'll need to disconnect the wire harness here, and also remove the 2 bolts again that hold the wire leads off. So we will test across. This will be 1 and 2, and then we'll put our test probe leads on 3 and 4 here, and off the wires again we'll go back to the battery just like we did the starting circuit cutoff relay. And now to actually test that starter relay, so we have our wiring hooked up from our battery to the correct terminals on there, and then we will have our meter again set for continuity, or the resistance there. Then we will take our leads and test it across points 1, and we have resistance. We have our continuity. Now, after checking the starter relay, we will need to check our main switch. In order to test that switch, we will need to find our wire connectors. The wire colors that we need are, well, one of the connectors is red and brown, and then the other connector will have a blue with yellow tracer and a blue with black tracer. And see, those are located underneath the frame here. And we have our red and brown tracers, or red and brown wires here, and our blue and yellow with our blue and black. So we will test across those and do that. We'll switch our meter to ohms, and as you can see, we'll set our leads up to connect to the prongs. The leads do not make a difference on where they connect to, just as long as they touch. We will turn our camera there, our ignition switch on, and we should get some resistance. It's very little, it's 0.2 ohms, so we are good there. Turn that switch back off. We get nothing. And we will test the other connector. The same process. Just the leads touching. And we want to test our ignition switch, turn our switch on, and again we have resistance. So that switch is good. Now we're going to be testing our engine stop switch, and we'll do that. We'll again set our meter into ohms for resistance, and our connector is here for this. The wire coloring is for the stop switch. Our 2 red with white tracers, a blue with white tracer, and a black wire as well. Disconnect that, and we'll be testing across the 2 red white tracer wires. I've got some a little bit extended leads on here. That's my recommendation. If you can get some, if you don't, kind of makes things a little bit more difficult to get a good connection on there. And then we will go ahead and depress the stop switch, and we should get some resistance there when on, which we do. Turn it back off. We don't have anything. Since we just finished up the engine stop switch, and we'll go ahead and test the engine start switch since it's in connection with the same harness. Do that, we'll be testing across the black wire and the blue with white tracer wire. Set our leads in there. We will test switch in the open position. It should be obviously open. To close the circuit, we'll press our engine start switch. You see we are getting some resistance, which is good. Next we'll be testing our neutral switch, and in order to do that is in conjunction with our shift lever here. And if you see, it's tucked underneath the wiring that we need. The connection to the case is underneath here, and it traces all the way back up through this area here, and it is a sky blue wire. And here's our connector tucked back in here. So we will just remove that, and we will test across there. We will take lead and insert it into the connector there, and if we are in neutral, we should get a reading, which we do, around 81 ohms. Now if we depress our shifter lever, it should take it to 0, which it does. All right, going to test our side stand switch. In order to do that, we'll have to trace our wire from the switch, from the side stand, up, comes up across here. It is this white connector with 2 black wires. We'll go ahead and disconnect that here. Set that out. And we'll test for resistance, set your meter to ohms. We'll test across these 2 points, 2 wires. And with it up, we should get some resistance, which we do. And once we actuate the kickstand switch down, it cuts out that system there, so we don't have anything. Now we are going to check our clutch switch, and based on where the manual specifies its harness connection is right in here, and we should have 2 black wires for that, which we do. I already kind of pre-disconnected that. And then we will test for resistance. You'll set your meter into ohms, and you will test across the 2 portions here. And pull your clutch in, and see we get some resistance in there. It kind of spikes around in there a little bit, but back out. Now again, this test was just to diagnose your no crank situation on your motorcycle. Our bike was again already running prior to this test, so we just kind of took it down to show you what you needed to test. If everything turned out okay on the parts that you were testing, and you still have a no crank situation, well, you may have to dig deeper into your wiring diagram and make sure that your wires are all good throughout your system. Thank you for watching. Hope you learned something. Look forward to new videos.
Subscribe.